This is lecture 17 on urban transportation planning. We will continue our discussion on modal split analysis in this lecture. To take a brief recall of what we did in the previous lecture, you may recall that we essentially discussed about two numerical examples involving the application of logit model of mode choice. The first example, two modes or two alternative modes were considered. The modes considered were motorized two-wheeler and bus, and the utility functions used were attribute specific utility function. The second example was the extension of the first example with the additional information that a new mode, namely rapid transit, is proposed to be introduced along with the existing two modes of motorized two-wheeler and bus. Since the utility functions were attribute specific, it was possible for us to consider the case of introduction of new mode also, and we analyzed the mode choice among the three alternatives and understood clearly the application of logit model for a mode choice situation involving three modes. Now in this class we will discuss a specific case of analyzing mode choice for a binary choice situation where only two modes are involved, and we will also see that the application of logit model of mode choice can be transformed into a simple linear regression equation, which will be easy to handle as far as analysis is concerned. We know this is the general form of the logit model of mode choice. Probability of choice of mode J is given as e power Vj divided by sigma k is equal to 1 to m e power Vk, and Pj is the probability of choice of alternative J, and m is the number of alternative modes including J. If there are only two modes available for travel, then we can write P1 to be equal to e power V1 divided by e power V1 plus e power V2, isn't it? Or P of 2, probability of choice of 2, will be e power V2 divided by the same denominator e power V1 plus e power V2. Let us consider a similar situation involving two modes, namely bus and rail, and see how the application of logit model can transform into a simple linear regression model. Let P of t and P of b are the probabilities of choice of train and bus respectively for travel in a particular context. Then we can write probability of choice of train to be equal to e power Vxt. T stands for train, x indicates the independent variables involved in the utility function. That is the significance of this subscript for Vxt, right, divided by e power Vxt plus e power Vxb. Okay. And similarly we can write probability of choice of bus B to be equal to e power Vxb divided by e power Vxt plus e power Vxb, isn't it? Now let us do a small manipulation to get the final intended result of a simple linear regression equation. you just divide the probability of choice of train by probability of choice of bus, Pt by Pb, can be written as shown here. We can write that as simply e power Vxt divided by e power Vxt plus e power Vxb whole divided by e power Vxb divided by e power Vxt plus e power Vxb. Denominator is same for the terms on top and bottom. So, we get simply P of t by P of b to be equal to e power Vxt divided by e power Vxb, is not it? And for a situation where we have information about the travel data, or when travel data are available, the condition when travel data is available means what? The values of Pt and Pb are known. Let us say about 45% of travelers are using bus, 55% of travelers are using train. Since the data is known, we can take probability of choice of bus to be 0.45 and probability of choice of train to be 0.55, isn't it? Because the information is known to us, even though it is the real choice, but for this equation purpose nothing wrong in taking the known percentage of share by the two modes as simply probability of choice. That is how the model has to be calibrated in practice, right? And we can write as given here capital P of t. Capital P is to differentiate from the probability, it is real share, divided by capital P of b is equal to e power Vxt divided by e power Vxb. That is nothing but e power Vxt into e power minus of Vxb. We can write that way also. Now let us do one more manipulation at this stage. Let us take logarithm to the base e on both sides, so that the value does not change for the involved variables. Taking log to base e on both sides, we get simply ln of Pt minus ln of Pb to be equal to Vxt minus Vxb. How do we get this result? Pt was in numerator, so we write ln of Pt, and Pb was in denominator with negative sign, so we get minus ln of Pb. That clear? On the right hand side we had e power Vxt minus e power Vxb. You may recall that is the equation we had. Just look at this, is what we do, we take log to base e for this equation on both sides, right. So simply when you take log to base e of this term, it becomes a V of xt multiplied by log e base e, is not it, right, and log e base e is 1. So we simply get Vxt, right. So that is how we get on the right hand side Vxt minus Vxb. Clear? The deterministic functions Vxt and Vxb can be expressed as follows. In fact, they are deterministic utility functions pertaining to train and bus. Now we need to get some functional form for these two utility functions. For that we need to know what are the variables or factors that we are going to put into the utility function. For a very simple case, the travel time and travel cost could be two important variables or factors which can go into the utility function, travel time and travel cost. So that is what has been done in this particular case to demonstrate the conversion of logit model into a simple linear regression equation. Cost and time have been taken to formulate the utility function for both train as well as bus. So we can write Vxt to be equal to a constant term k plus a1 times Tt, Tt is nothing but travel time by train, plus a2 times q plus a3 times Ct, Ct stands for cost of travel by train. Interestingly, we find a term q. This became necessary because of the fact that when the travel distance involved is more, whether it is metropolitan area or intercity travel, when the distance involved is more, people prefer train rather than bus. I think all of you appreciate this point. When the distance involved in travel is more, even in metropolitan areas, if the commuting distance is 20 kilometers and more, traveling in bus is strenuous. If there is an alternative like train service available, people choose train. Why? The space available per passenger in square meters by virtue of the design of the two systems is more in train compared to bus. In addition, you have other facilities like toilet etc. inside the compartment, coach itself in train, which is not available in the case of bus. So these are all the additional advantages with train. So when the distance involved is more, people choose train or have a preference towards train compared to bus. And how to bring in this fact into your modeling process? This can be done by segregating your data set based on travel distance. You have some dividing line. If the distance is more than that dividing line, you give some value for the variable q, which is a binary variable here or dummy variable. And if the distance is less than the dividing line, you can say the value of q is 0, isn't it, as we discussed earlier. So q is nothing but a dummy variable to take into account the preference of travelers towards train when the travel distance is relatively more. This has to be brought into the modeling process, otherwise we will not be able to explain the actual mode choice situation which exists in practice. That is the reason why we have introduced q here, particularly for Vxt, utility function for train. Utility function for bus looks like this. We have simply taken travel time and travel cost. Vxb is given as a4 times Tb plus a5 times Cb. Please note that q is not included in this utility function. Also, the constant term is missing in this utility function. There is no k or k1 or k2. Why? Obviously, when we introduce a dummy variable for one mode, there is no need to introduce the other one, because dummy variable becomes necessary in comparison with the two modes. We compare bus and train, and then we realize that train is preferred when the travel distance is more. To account for this fact, we are introducing dummy variable in respect of train. So that takes care of this particular aspect. There is no need to introduce another dummy variable for the other alternative, because q takes care of the travel time of both the modes, right. And why we have not introduced the constant term here as we have done in the case of train? Any suggestion? You may recall we discussed about base mode in mode choice analysis. What do you understand by base mode? Base mode is the one where we consider the unexplained part of the utility function to be 0, is not it? So, in this case bus is taken as a base mode, clear. So, that is how k is not included in the case of utility function for bus. Of course, the explanation for all the notations are given. K is the mode specific constant, and Tt and Tb are the travel time variables for train and bus respectively. Ct and Cb are the travel cost per kilometer per passenger for train and bus respectively. Q is a dummy variable to account for the convenience of rail for long distance travel. A1, A2 etc. are parameters to be estimated, right. Let us substitute the values of Vxt and Vxb from equations 6 and 7 respectively in equation 5. We are substituting the values of Vxt and Vxb as given in equation 6 and 7 in equation 5. Let us quickly try to recollect equations 5, 6 and 7. This is equation 5, equation 6, equation 7. So, we substitute the values of Vxt and Vxb in equation 5. Instead of Vxt, we are going to write the quantity on the right hand side of Vxt, and instead of Vxb we will write these two terms here. That is what we are going to do by this substitution process. We get ln of Pt minus ln of Pb to be equal to the first utility part for train, k plus A1 Tt plus A2 Q plus A3 Ct minus A4 Tb plus A5 Cb, clear. Let us do some simplification or rearrangement of the terms like this. This can be written as k plus A1 Tt minus A4 Tb. I am bringing the similar variables together, A1 Tt minus A4 Tb plus A2 Q plus A3 Ct minus A5 Cb, right. And substituting these values in equation 5 again, we get this simplified form of the same equation. It is nothing but the same equation. I have made some variations in the notations. There were two values multiplying Tt and Tb in the previous equation. Instead, I have put Tt and Tb within parenthesis and taken one constant term. It is just representative constant term, it can be done, right. Are you able to follow? See, what you do in the previous case is A1 Tt minus A4 Tb, right. Travel time by train is multiplied by a constant, some coefficient, and then travel time by B is multiplied by A4. Of course, we are yet to decide about the values of these coefficients, right. In any case, the travel time difference will be multiplied by some factor. So, instead of writing like this, I can write simply as A1 times Tt minus Tb equivalent, because we are yet to evaluate, we have to evaluate one coefficient. So, nothing wrong in writing as given here, right, and plus A2 times Q plus A3 times Ct minus Cb. Let us further try to reduce these notational aspects, and the linear regression equation equivalent to the above equation can be written as follows. We can write P to be equal to K plus A1T plus A2Q plus A3C, a very simple linear regression equation. On the left hand side you have a dependent variable with the notation P. On the right hand side you have 3 independent variables T, Q and C and a constant term K. You can afford to write this way because you know what is P. P means ln of Pt minus ln of Pb, isn't it? T is nothing but Tt minus Tb, travel time difference for any travel from an origin to a destination between train and bus. Q, you know what value to be substituted depending upon the distance involved, and then C is nothing but Ct minus Cb, travel time cost difference between train and bus. In practice, if you know the actual share of travel by train and bus, time difference and cost difference, you can simply calibrate this regression model. You will be able to find out the values of K, A1, A2 and A3. Once you calibrate a model, the model is ready for application for any given situation. Let us say you are able to calibrate the model and you want to find out the value of P for a given situation. You just find out the value of travel time difference, travel cost difference, and check the value of Q depending upon the distance of travel involved, and constant term is known to us. We can get the value of P, and from that it should be possible for us to find out the probability of choice of a particular mode. We will just proceed and see how this can be done. Of course, here P is a dependent variable, as I mentioned to you. T, Q and C are independent variables, isn't it, and A1, A2, A3 etc. are the coefficients to be estimated. Are you able to appreciate the method of manipulating the logit model of mode choice to get a simple linear regression equation? We are not doing any magic, it is just systematic mathematical procedure. So, for a binary choice situation you can use simple linear regression equation, still analyze mode choice. You can find out the probability of choice of a particular mode. Now, the equation 2 can be modified to find the probability of selecting bus mode as follows. I will give the equation 2 again here. This is equation 2 which we saw initially. Probability of choice of bus can be written as e power Vxb divided by e power Vxt plus e power Vxb. Now, let us divide the numerator and denominator of the above equation by e power Vxb. We are dividing the numerator and denominator on the right hand side, okay, so that the value does not change, and if you do so you will get this result. P of B will be equal to 1 divided by 1 plus e power Vxt minus Vxb. What is P of B? Probability of choice of bus, right. We get this probability using this very simple equation, which is nothing but 1 by 1 plus e power Vxt minus Vxb. Do we have the value of Vxt minus Vxb with us at this stage? If you go back and see, this is nothing but Vxt minus Vxb, right hand side is nothing but Vxt minus Vxb. So for any given situation it is possible for us to get these values once you know the travel time difference, travel cost difference, value of q and the already calibrated value of k, you can find out the value of Vxt minus Vxb, right, and simply substitute that value here. So this term can be evaluated using the linear regression equation and substitute that value in this equation 10 to get P of b. Once you get P of b, 1 minus P of b is P of t, isn't it? So that is how we can transform logit model into a simple linear regression equation for a binary choice situation, and for a given situation we will be able to estimate the probability choice of any mode, right. Once you know the travel time difference, travel cost difference, the distance implication, as per this model it should be possible for us to find out the probability of choice even for any given future situation, right. Now with this understanding, let us take a case study where we have actually collected data and use this model for a binary choice situation and calibrated the regression model so that the model can be used to predict the mode choice situation in the horizon year. The example pertains to intercity travel, does not matter whether it is intracity or intercity, mode choice is always mode choice. The factors influencing mode choice are not going to change, it is again going to be related to travel time, travel cost, comfort and so on. So we are going to discuss an example involving intercity travel, but the principles involved are same. The cities considered for this particular case study were spread over space covering 2 states, Tamil Nadu and Kerala states, and you can see there are 4 cities involved in the state of Kerala: Trivandrum, Trichur, Palakkad and Ernakulam, and 22 cities apart from Chennai are in Tamil Nadu state. In total, travel from Chennai to 26 other cities spread in 2 states were considered for calibrating a binary choice modal split model as a simple linear regression equation. When you think of mode choice analysis for this kind of a situation, you must very carefully study the system characteristics. If you take train service, normally train service is scheduled on weekly basis. Some trains may operate only few days per week, may not be on daily basis. Some trains may be operated on daily basis, whereas bus services will be operated on daily basis. Okay, this is one difference which has to be accounted for. Then if you take train, you have differential pricing. You have first AC, second AC, 3-tier AC, then sleeper class and so on. Whereas in buses, mostly normal buses or sometimes air conditioned buses, not much of variation as far as price is concerned. Now how do we collect the data required for the analysis? It's a question. First let us look at the weekly and daily basis of travel. Since scheduling of train service is based on week, we have to necessarily collect weekly travel data, right, to get the value of PT and PB. So, collect the weekly data and then get the daily average, right. Similarly, collect the data pertaining to bus travel for the same week and then work out the daily average. Even though you have daily travel data, still it is better to collect for 1 week and then get the daily travel data. So, these travel data, the value of PT and PB are going to be daily average travel by train and bus. Then travel by which particular class in the case of train? Can we compare or put all the classes together in the train, compare with bus travel? We should not. We should realize that socio-economic characteristics of travelers also influence mode choice. A person who normally travels by second AC will never choose bus as an alternative mode, isn't it? So, economic status comes into the picture. So, when you try to compare mode choice between bus and train in the case of intercity travel, it is more appropriate and logical to consider only sleeper class travel in train and bus travel. Okay. So, this is affordable for a particular section of the society, middle income group. They may either choose bus or simply sleeper class in train, second class. So, when you collect data, you should eliminate travel data by upper classes in the case of train, collect data pertaining to only sleeper class and compare with the bus travel data, right. Your database creation is very important. Another related question is, in reality, in most situations in our country, the demand for train travel is normally more, and when tickets are not available in train, people get pushed to bus, right. There will be a pushback demand for bus service because people do not get seats in train. That is one situation. Another situation is that some people reserve ticket in advance and some travelers just come at the time of making the trip and get into the bus or get into the open compartments in train and travel without any planning, prior planning. So, when you collect travel data, should we have to account for all this total travel information, or is there any rational way of collecting the travel data? It would be appropriate if we consider only data pertaining to reservation, reserved tickets, both in train as well as bus. Bus system also has got its own reservation system, right. So, consider only data pertaining to reserved passengers in both the modes, because they think carefully, decide about the choice of mode, then reserve ticket. They have considered all aspects and then reserve their tickets for travel, right. So, that is how you must zero on the data requirement for your analysis, right. It is only reserved ticket based on weekly travel, but converted into daily average, right. Unreserved travelers are eliminated, and also you must take into consideration denied travel because of the inadequate system capacity. Sometimes both trains and buses will be full, and under such condition, if you collect your data, the mode choice situation may not be reflecting the true scenario. So, look for a time period where the demand is not very high, demand is not exceeding the capacity, okay. and collect your data at that point of time, so that everybody who desired to take a particular mode was able to get a seat, a berth, and then able to make the journey. Normally under our condition, in this condition pertaining to these two states, September was found to be having quite normal demand, not any peak demand condition. So data pertaining to the month of September was collected. In fact, a monthly data was collected, even though weekly is sufficient. Data pertaining to 4 weeks were collected, and then daily average was worked out, both in the case of bus as well as train, so that data is more consistent and reflects the overall average travel pattern. Clear? Now let us have a look at the database. This is the information collected. Please remember, when we say % trips per day, it is daily average of 1 month travel for both the modes, but it is daily travel data. Okay, and the travel time in hours, the actual travel time, okay, as per their timetable, and travel cost per kilometer was worked out considering the minimum of the travel time involved in a particular city pair, considering the two modes. If you work out travel time per kilometer taking different travel distances for these two modes, that will not reflect the real influence of the time, right. Consider both the modes, look at the travel time, take the minimum of the two, and then total cost, travel cost is known to us by train as well as bus, right. Work out those costs by the same travel distance, so that the relative, right, merit or demerit of each of the modes for that particular city pair is reflected. Do you understand? For a particular city pair, the train route may be little circuitous, bus route may be little shorter. In that case, what will happen? More people might choose bus compared to train, right. So this has to be brought into your modeling process. That is why for each city pair, take the shortest distance, then divide the total fare by train as well as bus by that distance to get per kilometer fare. That is what was done. The numbers that you see here are worked out based on this particular logic. And you can see, interestingly, in all the cases train fare is higher than bus fare, in spite of the manipulations done in getting. It is true at the time of doing the calculation, most situation train fare is more than bus fare per kilometer rate, and the travel time, of course, it varies, and you can see the influence of travel time on modal share. You take this case, travel from Chennai to Salem, the travel time implication is just 5 hours, 5.44 by train and 7.5 hours by bus. The share is almost same, 300, 400. When the travel time is more than 10 hours, say for example, let us say Madurai, 10.21 travel time, right. You can see share by bus is decreasing considerably and rail share is increasing within the state. And if you take interstate travel, because interstate bus service is limited, the availability of seats in the buses becomes much less. So that is also one of the factors. Okay. The system itself is like that. Because of that, you see for Ernakulam, for example, the travel time is 11.48, 200 by train and only 13 by bus. It does not mean that only 13 passengers travel by bus because there are no seats available in bus. There is no demand for bus service for very long distance. Okay. services are operated based on demand. So that is how you must understand these numbers, very interesting numbers, very widely spread, the range is very wide. And look at the dummy variables. Can you guess the range of travel distance that might have been considered to give value of 1 and 0 for Q from this table?
The travel time difference between the rail and bus, when it was just less than 2, they preferred bus, and as you said, intercity they preferred train, interstate they preferred train.
That is fine. My question is related to fixing a limiting value for travel distance. Travel time can be fixed as a limiting value, but travel time depends upon the route length also. So that is how travel distance was found to be convenient to be a criterion, a limiting value to assign values for Q, and 400 kilometers was the limiting value fixed to assign value for Q. If the travel distance is less than 400 kilometers, the value was 0, and if it is more than 400 kilometers, Q will take the value 1. Okay. 400 kilometers means approximately how many hours of travel? What is the average journey speed by bus or train under our condition? About 50 kilometers per hour maximum, isn't it? 50 kilometers per hour journey speed maximum at the higher side. Okay. 50 kilometers per hour means to travel 400 kilometers how many hours? 8 hours. Obviously when the travel time is more than 8 hours, we prefer more train than a bus. So that is how, in fact, a passenger interview survey was conducted for this purpose to fix this 400 at the railway station, and based on the response given by the train travelers, 400 kilometer was taken as the limiting distance to assign value for the dummy variable. Okay. And similarly for other city pairs, there are totally 26 city pairs involving Chennai and all other cities, and you can see the very small values like 11 trips only per day in the case of Trichur and so on, and you can see in general that the value of Q is most cases 1 and in very few cases it is 0, okay, because it is a comparison between train and bus for intercity travel. It is better to avoid very short distance travel like Chennai to Chengalpet involving less than 100 kilometers. There will be so many other services available, even van services may be run. So it may not really reflect the true mode choice situation unless we take all other possible modes into account. Keeping that in mind, the minimum distance involved was also considered as a criterion while choosing the city pairs. Okay. Now model calibration was done using this information. What is the information available to us? The actual travel by train and bus is known, right? Capital PT and capital PB is known to us. So we know the value of P, isn't it? ln of PT minus ln of PB will give you the value of P. So the left hand side information is known to us. On the right hand side, we know the value of Q for every city pair. We know the value of T, TT minus TB is known to us. We know the value of C, CT minus CB is also known to us, isn't it? Substitute all the known values and get the values of the coefficients. So this is how the regression equation was calibrated, and this is the result of calibration. Even though it is a simple regression equation, you must accept this as your mode choice model for a binary choice situation. When there are two modes involved, this is a model. You can directly get the mode choice, probability of choice of any one of the alternative modes. And R squared value was quite high, 0.883, and F statistic, those who are not familiar with the F statistic, you will come to know later when you take the probability and statistics course, is also an indicator of overall goodness of the regression model, right. And T values were also calculated and were found to be much higher than the table value of T. So the model was found to be statistically significant. What is your comment about the logical correctness of this model? You have some plus and minus signs. More the travel time, less will be the demand for a particular mode. See, travel time will have a decreasing effect on the dependent variable. Travel cost also will have a decreasing effect on the dependent variable, right. Since we have a dummy variable taking values of 0 and 1, it should naturally have a positive sign. So we can say this model is both logically as well as statistically sound. And it is better to check for the validity of the model. In practice, it is better to apply this model for another situation where you actually know the modal share, use the model and get theoretically the modal share and compare the actual observed and model estimated modal share and check whether both are reasonably the same. That is what was done in this particular case. For this purpose, the modal split in intercity travel from Chennai to 5 other cities for which the actual travel by rail and bus were known was predicted using the model, and the actual known value was compared with the model predicted value. This is the comparison. The city pairs considered were Chennai Nagarkovil, Chennai Pollachi, Chennai Tirupur, Chennai Karur and Chennai Nagapattinam, 5 city pairs. You can see of course distances for information are given here, and in this particular case you have q value to be 0 for the 2 city pairs and the other city pairs will have q to be 1. Actual travel by rail and bus are given here and predicted values using the model are given here, and percentage error is also shown here. It varies. In one case for Karur we get minus 15.1, okay, and for Pollachi we get minus 12.8%, okay, and there are special reasons for getting little higher value, okay. If you look into the actual route followed by the 2 modes, right, and other alternatives available over part of the stretch, etc., you will be able to reason out for the higher error, but overall this kind of error up to 12%, even 15%, when you take things at a macro level, it is possible to get such error, but you should not get carried away by erroneous result in one city pair, okay. If you want to make sure, apply the model again for another set of data and check for the correctness, okay. In a particular case the error may be due to some specific reason. Nothing wrong in getting erroneous results, only thing is you should be able to reason out as to why you are getting erroneous result. If you are able to, then you are a successful modeler, okay. Generally we can say that this model is acceptable and good enough to analyze mode choice for a binary choice situation. This is fine, but for decision makers, if you want to really present your analysis for the purpose of making policy decisions, how to present your model, it is a question. Ideally we must present the results of any analysis in a pictorial form. Graphical presentation is more impressive and easy to understand by managers and decision makers, right. For the purpose this kind of plots are made, it is nothing difficult. What we have done is we have taken the difference in cost per kilometer between train and bus, Tt minus Tb is taken in x axis, right. Probability of travel by bus is taken on y axis, and we have made different plots for different travel time differences, considering one case where q is equal to 1. We have considered city pairs with travel distance more than 400 kilometers. If that is the situation, this is the result of your mode choice analysis, right. Let us say currently Tt minus Tb is 0.03, and the system manager, the train system manager is interested to know what will happen. Of course, the travel time, let us say it is no difference at all, then the share by bus for this given situation is about 20%. Probability of choice of bus is going to be 20% if the t value is 0.03 and t value is 0, the probability of choice of bus is going to be 0.2, am I right. Let us say the railways is interested to increase the fare in such a way that the cost difference Tt minus Tb becomes 0.06, okay. And for the same situation where there is no travel time difference at all, what will happen, what will be the implication? You will find that the share by bus is going to be at least 25%. There is going to be a shift of travelers from train to bus, so that the share of bus increases by 5%. Very simple presentation of the results. This is what the system managers look for. If I do this, what will be the scenario, what will happen to my operating system, whether I will be losing, if I lose, to what extent, right. So this is how we can present the modeling results, so that it is really a useful tool for decision making process. A similar presentation can be made for a case where q is equal to 0, when travel distance between city pairs is less than 400 kilometers, right. So with this we will conclude our discussion for today. To summarize, we started our discussion about application of logit model for a binary choice situation, and then we found that it is possible to manipulate the same logit model to get transformed into a simple linear regression equation, which can be used to analyze mode choice situation when only two modes are involved. Then we have also seen a case study involving intercity travel between involving the choice of train and bus, and we discussed this example with specific reference to the complexities involved in data collection process. We have to be very careful in creating the database. Once your database is perfect, then modeling process can be very smooth, giving you very useful results. We will continue the discussion in the next class.